Good afternoon, Chairman Chen, distinguished guests. I'm Chen from KENMEC. First of all, I would like to thank Chairman Chen of Innodisk for the kind invitation, which gives KENMEC the opportunity to participate in this grand event and to share with you our experience as a system integrator in automation solutions, particularly in the area of AI, digital twins, and physical AI applications. Today's presentation will be structured around 4 key themes. First, we will introduce KENMEC, providing you with a clear understanding of our background and positioning. Next, we will highlight the importance of digital twins and the pivotal role they play in industrial transformation. Then, we will explain how to build the required hardware and the software platforms for digital twins on premises. Finally, by combining AI, digital twins, and physical AI, KENMEC aims to convey our value proposition and vision. KENMEC was founded in 1976 and have nearly 15 years of experience in smart automation and logistics system integration. Our business spans across automatic warehousing, semiconductor logistics, liquid cooling solutions, and large-scale public infrastructure projects, making us one of the most important companies of Taiwan's smart manufacturing and automation industry. At the same time, we continue to explore how to integrate AI application into our operations and products, building competitiveness while driving innovation. This is one of our digital twins projects developed with specialized software. The clients provide 6 months of operational data for simulation and validation. The result shows that only 5 inspection stations were actually required, a significant reduction from the originally planned 22 stations. Through this simulation, the client achieved clear benefits in space utilization, cost saving, and shortened construction timelines. We also applied this software to Taoyuan International Airport Terminal 3, which consists of nearly 38 kilometers of conveyor systems. By leveraging digital twins to validate physical PLC programs, we are able to confirm system operation even before the system was installed. This approach significantly reduced commission time and enhanced overall project efficiency. However, in these application scenarios, there is still a lack of an entry point for AI integration. This is exactly the direction we are continuously exploring: how to combine AI with digital twins to unlock even greater value. In 2023, we encountered NVIDIA Omniverse. Doesn't it do real? Through OpenUSD, RTX technologies, and accelerated computing, we are now able to achieve highly realistic simulation effects. What does this mean for us? AI can be trained in virtual environments. How should we look at this? If we want to educate children about the world, which kind of a virtual environment would we choose? Naturally, we would want our children to experience a world that is as close to reality as possible, not a distorted or fragmented version of it. This is why AI must be trained in virtual environments with true realism. Only then can AI learn the correct logics and behavior patterns to generate real value when deployed in the physical world. NVIDIA Omniverse is a platform that connects models generated by different digital twins applications into one unified, realistic virtual world, enabling AI to learn, train, and be validated within it. OpenUSD, Universal Things Description, is the core foundation that brings realism to digital assets. Through OpenUSD, we can transform digital assets from modeling, animation, control, workflow integration, training, forming a complete closed loop that provides a realistic foundation for AI and digital twins applications. OpenUSD is not only a technology, but also an essential digital asset for enterprises. From design, manufacturing, marketing, it connects the entire product lifecycle into one continuous flow. KENMEC owns domain know-how in the field of logistics. On the NVIDIA Omniverse platform, we have built a physical-based OpenUSD digital asset that can be decomposed, reassembled, and reconfigured according to requirements of different environments. What do we expect AI to help solve? We envision AI as a trusted assistant like Alfred, Batman's butler, helping us handle the troublesome and the repetitive tasks. Generative AI can support us by efficiently building OpenUSD and environment models, accelerating robot training workflow through synthetic data and synthetic motions. This allows us to stay focused on innovation and value creation. Here, our engineers have configured collision parameters to demonstrate the realistic physical rules within the simulation environment. We also hope the AI can be like Jarvis from Iron Man, helping us handle complex problems. Take automatic warehousing as an example. Determining the placement of ABC inventory categories is critical. With AI, we can run the calculations, simulations in a virtual environment without disrupting the actual system to find the optimal storage allocation plan. This helps enterprises enhance warehouse efficiency, reduce operational costs, and accelerate decision-making. What is the value of digital twins for physical AI? No three expensive solutions, helping us overcome the three expensive challenges. Data collection is expensive. In the real world, less than 10% of data can be effectively used for training. Some leading robotic CEOs even estimated the ratio to be below 1%. How to efficiently acquire high-quality data remains a core challenge in robotic training. Training is expensive. Real-world training requires massive investment of manpower and financial resources. With digital twins, simulation and testing can take place in virtual environments, dramatically reducing cost. Robots are expensive. Robotic hardware itself is costly and extends real-world testing risk, wear, and damages. Digital twins reduce the frequency and the risk of physical testing, ensuring both cost saving and system reliabilities. Physical AI is born in simulation. The virtual environment is the training ground for physical AI. Physical AI is awaiting its software moment. When we were at GTC, Jason said, "We are no longer making computers. We are making AI infrastructure for science." In building AI infrastructure for digital twins, the core components include the L40S GPU to support high-performance computing and NVIDIA Omniverse software. For robotic training, we recommend the NVIDIA RTX Pro 6000 combined with NVARE software to achieve optimal performance. KENMEC is also a NVIDIA solution provider. If you are planning to build an AI data center or deploy Omniverse solutions, we would be honored to be your trusted partner. Antenna debuts excellent MGX high-performance Edge AI server. The Antenna MGX Edge AI server integrates the 6th-gen Intel Xeon processors with NVIDIA GPUs supporting dual GPU configurations. With NVIDIA NVLink technology, unlock the full power of GPU accelerating, driving efficient AI inference, training, and edge computing. There are some advantages. Accelerated on-premises AI deployment. CPU plus GPU heterogeneous computing enables high-performance AI inference and training. Support for NVIDIA Blackwell GPUs provides powerful performance for next-generation AI workloads, advanced high-speed networking, optimized data transfer and distributed computing efficiency. Flexible deployment architecture supports both rack-mounted and non-rack environments, suitable for edge AI and the data center needs. We believe that the physical AI is a closed-loop simulation process, where the outcomes of the simulations must be validated and fed back in the real world, creating a continuous flow. This loop constantly improves the accuracy of the simulation to better reflect reality. At this year's Automation Exhibition, KENMEC is showcasing the latest technologies from the neural robotics. They are humanoid robots, service robots, cognitive robots armed from neural robotics, and the expansion robots, patrol robots from Yugo can be integrated with Innodisk products, including cameras and Jason Olin. Then we can say AI beyond the edge. The KMAI model begins with field planning to construct a virtual environment. Robots are then imported into the virtual space for learning and training. Once the model is ready, it is deployed into the physical world for verification and execution. The feedback from the real-world operation is continuously fed back into the virtual environment for further optimization. This creates a real-to-sim, sim-to-real closed loop, enabling the development of a general-purpose large model for collaborative operations for various types of robots across different application scenarios. I hope I gave you a new AI world in 20 minutes. I'm Chen from KENMEC. Thank you.